Good morning all. I am Virendra Kumar. I welcome to all in this video. In this video, I will explain about refrigeration. What is the refrigeration? Actually, suppose we want to cool or we want to reduce the temperature of a substance or a space, then what we will have to remove heat from the substance and space. Then we will have to apply one process. Then that process for which we are removing the heat from the space or substance, then that process is called refrigeration. So refrigeration is the process of heat removal from the space or substance to reduce the temperature. Generally what? Generally heat always flow from higher temperature body to lower temperature body. But suppose we want to reduce the temperature of a body with respect to surrounding, then what heat will have, we will have to made to flow from lower temperature body to higher temperature body. So that process is called refrigeration. It's for example, I am just taking this space is there. Okay. Now ambient condition, suppose 31 degrees centigrade. Then inside also 31 degrees centigrade. Then now we want to cool this place. Then what we will have to remove heat from this space or substance, and we have to transfer the heat into the surrounding. Then that process is called refrigeration. Generally what, suppose here low temperature, outside is higher temperature, then always heat or naturally it will come from here to here. Suppose this is suppose this is 15 degrees centigrade and surrounding temperature is 31 degrees centigrade. Then what happens? Heat automatically it will get heat and its temperature will increase. But suppose we want to come down, reduce the temperature of this body, then we will have to continuously remove heat from that space or substance. So refrigeration is the process of heat removal from the space or substance to reduce the temperature. Now some methods is there to produce the refrigeration. Generally first we are ice refrigeration. Very common refrigeration methods we are using in also now village or suppose we any water bottle refrigerator now there, then we are purchasing the ice from the market and we putting the ice in a one container and naturally heat transfer a higher temperature body to lower, because ice is very lower temperature, then naturally heat transfer will take place and the substance will get cool. Second one method is dry ice refrigeration. Dry ice refrigeration. Here we are using ice. Now here we are using dry CO2, solid CO2 is known as dry ice. It here what happened? Ice converted into water, but here dry ice is directly converted into gas. And heat what happened? Cooling we will take we will take the cooling and or we will reduce the temperature of a body. Now third one method is liquid expansion. Liquid expansion. This one also, suppose we, what happen, we are generally we want to cool, then what we, suppose this place we want to cool, then we are spraying the water, then water here also, this is liquid expansion, also evaporative cooling. Second name is evaporative cooling. Evaporative cooling, because we are evaporative cooling, liquid expansion or evaporative cooling. We are expand the liquid, then liquid evaporate, and then surface or space will it will reduce the temperature. Now third one, here what suppose we are using generally, suppose vegetables, we are spraying the water will evaporate and vegetables or space will be cool. Now village side also, suppose more heat is there, then we are water surface side, we are spraying the water it will evaporate and the ground surface will get cool. Now fourth method, here gas expansion or gas expansion. This is also known as air refrigeration system. Air refrigeration system. What? Here we are compress the air and we cool the air, then expand. Then what happen? We will take place. We will take the cooling. In next video, I will explain briefly this process. So next one, 5 here, vapor absorption refrigeration. Vapor absorption refrigeration. Number 6, vapor compression refrigeration. Compression refrigeration. Thermoelectric refrigeration. Thermoelectric refrigeration. Generally 7 is there. Now standard here, one thing, its refrigeration standard unit is ton of refrigeration. Actually ton of refrigeration is heat required to melt 1 ton of ice into 24 hours. Because in previous before in olden days, we are using, here I also told, it is very oldest method to produce refrigeration. So ice, we are using ice. Then what? For suppose how much kg we are in generally 1 TR. 1 TR means 1 ton of ice. Suppose 1 ton of ice, it will give cool or it will absorb the heat. Because how it will give cool? First it will absorb the heat. Heat transfer will take place between the substance and ice. Then what? Ice will absorb the heat from the substance to be cooled. Then ice will convert into water. Then for converting water, to solid for solid ice, then what that heat it take from the space or substance to be cooled, then temperature of that substance or space will be reduced. Then suppose 1 ton of we are using ice, then what is that heat removal, that heat removal for from 1 ton ice to another from substance to be cooled, then that is called 1 ton of refrigeration. Because 1 ton, here we are 1 ton equal to 1 ton, 1 ton here US ton equal to 907 kg. In metric ton, equal to 1000 kg. For heat calculation purpose we are taking 907 kg. So 1 tr equal to 907 kg into, for 1 kg to melt 1 kg of 1 kg of ice for melting required 80 kilocalorie heat. 80 kilocalorie heat. So 907 kg melting heat equal to 907 into 80 kilocalorie. Because it required for 20, it will we want to take we want to take cooling for 20 hours, so it will divide it by time, 24 hours. Then we will get here 3024 kilocalorie per hour after calculation. Now again we will get here 50.4 kilocalorie per minute. Now because 1 kilocalorie equal to 4.18 kilojoule. So putting this value, this value, that value, we will get here 50.4 into 4.18 kilojoule per minute. So we will get 211 kilojoule per minute. Now again we will convert, then here we will get 3.5 kilowatt. So 1 tr equal to 3024 kilocalorie per minute, 50.4 kilocalorie per minute, per hour, and 50.4 kilocalorie per minute, and 211 kilojoule per minute, and for with calculation we will get 3.5 kilowatt. Now I hope you have to understand type of refrigeration, and I also clear ton of refrigeration. Okay, thank you.